Okay, just a quick video to show you how to rearrange the select and apply equation v squared equals u squared minus 2as. Of course, you need to know that v stands for final velocity, u stands for your initial or starting velocity, number 2, a stands for acceleration, and S stands for distance. Okay, so let's say if we want to rearrange that equation to get A on its own, so acceleration, so let me just rewrite that for you here, the main equation. Obviously that means 2 times A times S. Okay, so to get A on its own, you've got to think about how you get rid of the 2 and the S on this side of the equation. So you would do that by dividing by 2 times S. What you do to one side of the equation, you have to do to the other side. So these now cancel out, leaving A on its own, and then we normally write it the other way round. So we normally say A equals V squared minus U squared over 2 times S. Okay, so that's an easy rearrangement. Something slightly more complicated is to get V squared on its own or U squared. So I'll show you how to do that and then I'll give you an example. So I'll just again rewrite out the equation. Times A times S. And then for V squared, if you want to get that on its own, and be careful here because this is minus u squared, it's not multiplied by, so we are not dividing it this time. In order to get rid of the u squared on this side, if we want to find out what v is on its own, the first thing to do is get v squared on its own, so we need to get rid of this. So the way we would do that, if you add u squared to this side of the equation and do the same to the other side of the equation, remember that's multiplied, those are multiplied together. Okay, now these two cancel out. Okay, so just remember this is not multiplied by, this is minus, so to get rid of it we're having to add it on this side. Okay, so that leaves v squared equals 2as, 2 times a times s plus u squared. So we've still got v squared at this point. So to get v on its own, v is simply the square root of the other side. Okay, put that bracket back in. So just be careful that you put things in the brackets and do that first before you do the rest, and then you square root the result of it. So I guess you'd like to see this as a question, and perhaps also want to just do the same for u squared as well. So that's what will make our next step. Okay, so let's just put a question in that I've just written out earlier. So here we've got a marble, just swap to a pen, travelling at 0.2 meters per second. Oops. We'll go for a pencil. 0.2 meters per second across a table when it's accelerated at 9.8 meters per second squared over the next 0.2 meters. What is its final velocity? Okay, so I always start by writing the equation that I'm going to use out. And I've just said to some students that it's helpful to circle the values in the equation, in the question, so that you can pop them into the equation. Okay, so we're after this one. So it's being accelerated at 9.8, so that's our acceleration, that's our A. That's our 0.2 meters, that's our distance, that's the S part of the equation here. It's already travelling at 0.2 meters per second, so it has an initial speed, so that's our U. Be careful if the question says it's travelling, it's at rest, then that means it's not got a speed, it's obviously stationary. Okay. So next step then is to get, we're after the final substitute in the numbers we know. That's what we're going to do first of all. Okay, so v squared minus, there's our 0.2, our u, okay, squared. By substituting in the numbers that we've already got in the equation, I guarantee we'll get the mark for substitution in the exam. So that's just a trick to make sure you score that one. Okay. Alright, so now we've got to get rid of this 0.2 squared from this side of the equation, and remember it's minus, so to write it out longhand, what we're effectively doing is we're adding on 0.2 squared, and then we're going to do that to the other side of our equation. Okay, and now this will cancel out, plus 2 and our minus 0.2 squared plus our 0.2 squared, so effectively leaving v squared on its own. And at this point here I would then do the math, so 2 times 9.8 times 0.2 is 3.92 plus our 0.2 squared, and 0.2 squared is 0.04, so our v squared equals 3.96. Okay, so to get v on its own, I'm going to square root that, so I'll square root of 3.96, v equals 1.99 meters per second, and then I'd probably just run through and check the maths again if that was your question. Okay, alright, so let's do a similar question just to practice that. And this one is an interesting one because here we've got something decelerating, and deceleration of course is a negative acceleration. So let's work through this one. So v squared minus u squared equals 2as. We're actually still going to work out the final velocity here. Okay, so it's travelling at 23 meters per second, so that's our, whoops, that's our u. Okay, there is its deceleration, so that is an acceleration of minus 2. It's a negative acceleration, it's a deceleration. Okay, and we've got our distance there. Okay, so drop those numbers into the equation. So we've got v squared minus 23 squared equals 2 times minus 2, that's our deceleration there, okay, times 112 being our distance. So we want to get v on its own. The long-winded way, you probably drop this step when you're a bit more comfortable with it. Remember it's minus, so we can't, it's not a divide thing. Those numbers you're going to want to pop in a bracket. Okay, plus 23 squared. So these two cancel each other out, leaving v squared on its own. We want to do the maths at this point, so 2 times negative 2 times 112 gives you negative 448 plus your 23 squared. 23 squared is 529, so your v squared equals 81, which means that v is the square root of 81, so v in this case is 9 meters per second. That's the final velocity of, and just check that you haven't, check it makes sense. Yes, it was travelling initially at 2 and 23 meters per second, which is obviously faster than 9 meters per second because it was decelerating. When they tell you it's decelerating, it's okay to give at 2 meters per second squared. When you use it, then its acceleration, which is in the equation, is a negative number. Okay? Alright, hope that helps.